Hello friends, I'm Ram Lakshmanan, architect of yCrash. In this session, let's talk about the clear API, which is there in the Java collection interface. So when you invoke the clear API, it's going to remove the elements from the data structures, right? That's what it does. Have you guys used clear API?
Yes.
Yes, Ram.
Okay, good. So in this session, let's talk about what is its memory impact when you invoke it. What is the processing time impact, right? Well, let's study about what is the performance aspects of this, okay? So for our discussion, I have put together a very simple example. Let's look at it. Let me share the screen. Okay, so friends, so this is a very simple example. If you see what I'm doing, here I'm creating an array list, right, which implements the Java collection interface. And here what I'm doing, look at this. I'm in this main method, I'm just going on a loop. I'm going on a loop for 1 million times. And then I'm adding that record in this array list. What I'm declaring here, I'm creating a mylist array data structure. And to this, I'm adding records 0, 1, 2, 3, 4, 5, 6. Till that, I'm adding till 1 million records, right? And then I'm just printing it saying all records have been added, right? All records have been added. So, and here I'm sleeping for 100 seconds so that I can capture certain diagnostic information which we needed for our discussion. Okay, friends, now let me execute this program. Right? I'm going to go ahead and execute this program. Okay, so I executed it. See, right now it just says all records have been added. That is all the 1 million records have been added. And while now this thread is sleeping, I went ahead and then I captured the heap dump. I used an open source script called as yCrash, which captures a 360-degree data from your application stack. And one of them is an heap dump. So I used this heap dump. And then heap dump is basically a snapshot of your memory, right? It shows what are the objects which is there in memory. It shows what are the objects which is there in memory, what is the value in it, who is referencing that. It has all those information. I took that heap dump and then I analyzed it with the HeapHero. That is, the heap dump is a binary file. It's a very large file. It's hard to debug. So I analyzed it with the HeapHero. Let's see what is its output showing, right? Let's look at that report. Okay. So here is that heap dump analysis report. Here it's showing what are all the biggest objects which is there in memory, right? It is showing all the objects, what are the biggest objects which is there in memory. Right? Here it has that clear node demo, that is the program, the entry class. And let's see, here it has this my list, right? This is nothing but the this list, what we are creating here, right? This my list, what we are. And now here underlyingly, every array list, every array list, it has an object array. So whenever you add any records, right, it goes and it says it's stored in as an object, stored in as an object within this object array. In fact, we can look at the source code. Look at this. So here, this is the array list. So if I'm going to click here, this is the JDK source code. Look at this. This is the JDK source code of array list. Look, it has an object array. This is element data. Okay, that's what you're seeing in here. So here you see this as element data. Here you can see there is more than 1.2 million records have been created. The size, the array object array size is 1.2 million records. Why it is 1.2 million instead of 1 million? That is a topic for another discussion, which we'll talk, right? Now, if I'm going to drill down here, I'm going to see all those 1 million records here, right? Whatever we added. See, let me click on one of them. Here you can see, oh, this is this value. If I keep moving, you can see this value to be changing, right? So this is all those 1 million records. Okay. Look at this size, friends. How much memory it occupies? It occupies 27.5 MB. Right? So this array list is occupying 27.5 MB of memory, right? Now, what we will do, here is I made a minor modification to our program, what we discussed just now. Look at this. Here there is the same array list. Here I'm adding those same 1 million records. And now what I'm doing now, I'm invoking that clear API. Right? We invoke this clear API. So when you invoke this clear API, all the elements within this my list is going to be removed from the memory, right? So now let's execute this program. Okay, I executed it. It's saying it took like this kind of 5 milliseconds time. And now when it's sleeping, I once again I captured the heap dump, and now I analyzed with the HeapHero tool. Let's look at what is now HeapHero reporting for this program. So what do you guys expect to see now? What do you guys expect to see? Do you guys expect to see the memory to be dropped from the 27.5 MB to all the way to 0? Or what do you expect to see?
Yes, because we are clearing, right? So it should drop.
Okay. So, okay, here is that heap dump analysis report. Okay, so we are expected to drop, right, to become as 0, right? Because we are clearing all those 1 million records from the memory. But friends, look what's happening. This clear demo size is 4.64 MB. So let me drill it down. Here, there's my list is 4.64 MB. Earlier, it was like a 27 MB, but now it has become 4.64 MB. It didn't become 0. Interesting, right? Why? Here, look at this element data, right? Look at this, okay. Look at this element data, this underlyingly, this element data object array still continue to exist in memory. The element, the object array, which is stored, it still continues to exist in memory, right? And here, but if you see, there are no elements in it. In our earlier report, we saw that elements to be present here, right? We saw all those 1 million records to be present. Now it says 0 entries. But this array continues to exist. There is an object array, the structure which holds on to all the 1 million records. This continue to exist. That's why it is taking this 4.64 MB. Even though the underlying data is eliminated. Do you guys see what's happening?
Yes.
Mm-hmm. So, right. So like if we have a empty data structure defined, then does it take this much size in the memory?
So, Mahesh, your question is, say if I'm going to just say array list instead of adding anything, is that going to take this much memory? That's what you are saying. Instead of, let's say I just define just this much, right?
Right. Right.
Then it's going to take this 4.64 MB. That is a question, right? That's a very good question. Actually, it will not. But when you define an array list, by default, the array list allocates a size of 10 elements. So only the space for 10 elements is stored in memory. But in this case, what we have done, we created 1 million records. So now that underlying array structure, the object array, it grow to 1 million plus size. That's why it is still remaining there, even though I invoked the clear function on it. Okay. Okay.
So is there any way to reset that?
Yes. That's my next very logical point. Now look at this. Here I put together this clear null demo, right? Here what I'm doing, the same array list, and here I'm adding it, adding the 1 million records. But look at this, instead of saying clear, here I am saying null. I'm assigning to null. And then now I'm going to be running it. Let's execute this. In a way, when I do null, right, I'm just clearing everything. Now when I say let's execute it. See, now this took 0 milliseconds. Earlier it took 5 milliseconds. It keeps fluctuating, but it is a little bit more. I will talk why it's taking 5 milliseconds earlier, right? It now became 0. Now I captured this heap dump, and let's look at that. Let's review that heap dump, how it is looking. Okay, look at it now, friends. Here, if you can see, now in this large object section, that our object is not even showing up. Right? It is gone. It doesn't occupy anything because we assigned it null. It means it's eligible for garbage collection. Garbage collection removed it. So we're not even seeing it here. Right? So using clear, right? Here you can see where using clear still has a memory impact, right? You are only destroying the objects which is present, but that object array which holds that all the objects is going to be still there. So that's going to consume memory. So in fact, I recall one trading application, right? It's a in trading applications, you got to pass the transactions in a matter of milliseconds, right? And that application and there's a very major application. And this application was starting to use clear, right? And when it was using clear, the response time was degrading, right? Because look at this, what's happening. Let's look at what's happening within this clear function. Let me go in to this clear function. So this is the source code of the clear function. Look at these two lines, friends, right? Look what's happening. Here it is, this, the thread is just going on a loop. Let's say you have 1 million records. Here it goes on this loop on all the 1 million records, and then it's assigning null. Right? It's doing it. So when that trading application was doing it, was taking more than few milliseconds to process. It was not acceptable. So then they assigned it as null, and then they got back into business, right? So the clear as these performance impact, that is, it's going to consume memory, and then it's also taking a little bit more processing time. So in general, I would prefer assigning null rather than using clear. But then people can ask whether then should we never use clear? Yes, there are cases where you may have to use. Okay, say suppose here you want to pass this array list to some other object, right? You want to pass this, and there if they are trying to invoke anything, if you're assigning as a null, then they may get a null pointer exception, right? Rather, if you're cleared and then sending it, they can invoke, they can make operations on it, right? And also this clear would have this kind of consequences only if you have large amount of elements, right? Very large amount of elements are stored. But in case if you're only storing few records, few elements into the array list, you can still continue to use this clear. Okay. Is this making sense? Any questions you have?
So is it a bad practice to use clear method?
See, there is no binary rule, bad practice, good practice, but I will try to avoid, given this the memory constraint, and given this one, unless there is some references to it down the lane in the application, then I will go for it. But typically, I will try to avoid. I will try to go for just passing as now. Okay. So, any questions, guys?
Yeah, clear API is only for list, or sets also we have clear API?
Okay. See, friends, this the clear API is defined in the Java collection interface. This clear API is present in the Java collection interface, right? So any data structure which implements this collection interface is going to have that clear API. So it's going to be there in the set as well, because set also extends this collection interface. Okay. Any other questions?
Yeah, what should be the basic difference between the remove all and clear API? Because we are using remove all many times, but clear API, I feel it should be the same.
Okay, so that is a very good question. We will talk about the details of it in a separate talk, but definitely we'll talk, Ankita. Okay.
Okay.
Okay. Thank you, friends. We will connect back with you with yet another interesting session. Thank you.